In the first half, I'm going to talk what is a data lake, talk about some key data lake concepts, and describe some of the services and techniques you might consider when building a data lake on AWS. And then in the second half of the session, we'll be hearing from our partners DataPipe and Cloudwick about the ways in which they're working with customers to build data lake solutions on AWS. At the end, we'll then have about 10 minutes where we can answer some of the questions that you may raise over the course of the session. So let's get started. What is a data lake? Well, in its simplest, I'd describe it as a strategic data capability that allows us to store all our data forever at every stage of its life cycle, and then apply it using specific services and tools appropriate to the task at hand. So with this kind of capability, it really provides for more agile analytics, allows us to leverage all the data that flows into our organization and to build more customer-centric, predictive and machine learning capabilities that give us competitive advantage. Now, a data lake isn't necessarily an alternative to or a replacement for a data warehouse. A data lake really allows us to store, catalog and govern our data in any form, structured or unstructured, whereas a data warehouse allows us to apply a structured subset of that data for reporting and BI purposes. Now, a data lake encapsulates 4 key concerns. We'll go through those very briefly, and then we'll look in more detail about how we can actually apply AWS services to realize some of these concerns. So at the lowest level, we're really concerned with ingest and storage. That's ingesting both batch-oriented and streaming data in whatever form, and storing it in a durable, highly available storage medium. On top of that, we then want to be able to provide cataloging and search facilities. So it's no good just dumping all of our data into our data lake. We need to be able to understand what data do we have, where does it come from, where does it reside, what format is it in, what schema does it have, and so on. What kind of business semantics are attached to it. We then also want to be able to secure and govern that data. We likely want to be able to encrypt it at rest and in transit, control access on a per dataset basis, and audit all of the applications, services, and users who are consuming that data. Finally, we want to be able to expose the data within our data lake to our end users, applications, services, and our end users who are applying it for analytics purposes. And so it's likely we'll also want to be able to introduce a UI or an API in order to be able to give access to the data that we're storing in our data lake. So that's the 4 key concerns or key capabilities of a data lake. How might we actually go about implementing that using AWS services? Well, before we look at some of those specific services and the ways in which we can apply them, I want to make one very important point. This diagram here shows a traditional analytics data pipeline. We're collecting data, storing it, processing it and analyzing it, and then finally consuming the results. Well, the value here is really realized at the end, where we consume that data that we've processed and we act on the insight that we've generated. Everything else is preparatory. The real analytics work is in the consumption and application of those insights. So everything else is preparatory. So actually a lot of what we really consider to be analytics isn't really analytics, it's preparation. And our data lake can help us in this regard. It can help us implement a lot of those undifferentiated core capabilities that prepare the data, store and prepare the data. And it gives us the freedom then to apply the data using a variety of different tools and techniques. So a lot of what we'll focus on over the next 20 minutes or so is this 80% undifferentiated heavy lifting, which is implemented in our data lake platform. So let's start with storage and ingest. Well, even with storage, it's a matter really of choosing the right tool for the job. So if you need a distributed file system, you might choose EFS. If you're looking for block storage to attach to a specific virtual machine, you might use EBS. And as we've seen in previous webinars, if you're interested in online transactional storage, then you might look at DynamoDB or something from the managed relational database service. But for analytics, object storage is foundational. And in AWS terms, that means S3, our simple storage service. So S3 provides a cheap, highly secure, highly durable storage medium for objects up to 5 terabytes in size. With S3, there's no need to think about capacity up front. S3 will scale no matter how many objects you write to it. And when you write an object to S3, it's immediately replicated to at least 3 physical facilities, providing you with 11 nines of durability. Furthermore, S3 is agnostic to the file format that you use, so you can store text-based and binary objects in S3, TSV and CSV files, JSON documents, Avro, Parquet, ORC, and so on. So in terms of it being a cheap, highly durable, highly available, secure, near infinite capacity storage service, S3 acts as the foundational layer for our data lake. But it's not simply dumb storage. S3 also offers an eventing mechanism and lifecycle management. So every time we create a new object in S3 or modify an object or delete it, we can treat that as an event, and we can use that event to trigger some downstream activity. We can attach Lambda functions, for example, that might kick off some ETL process. On top of that, we have some lifecycle management. We can attach policies to the buckets in which objects are stored, and we can use those policies to move data through several different stages of its lifecycle. So if we want to remove data after, say, 30 days, we can use a lifecycle policy to remove that data from S3. Or it may be that we want to move it into cheaper archive storage, Amazon Glacier. And again, we can use those lifecycle policies to move specific portions of our data within our data lake into the appropriate tier. So S3 really is that foundational fabric for our data lake. It provides for an unlimited number of objects. We don't have to think about capacity up front. We don't have to think about specific storage format up front. We can write whatever kind of object we want to S3. It provides 11 nines of durability because those objects are synchronously replicated across 3 physical facilities. We get lifecycle management and that eventing mechanism. Importantly as well, within the AWS ecosystem, we can expose S3 as though it were HDFS. So we've got native support for storing and consuming data in S3 from many applications within the Hadoop ecosystem. So things such as Spark, Hive, and Presto can treat S3 as their fundamental storage medium, consuming data from S3 and writing data back to S3. And this provides us with a very, very key capability, which is that ability to be able to decouple storage and compute. We can scale and provision and scale our storage quite independently of the specific compute resources that we apply to it, whether that is something such as Amazon EMR, our managed Hadoop environments, which we can spin up, apply some compute work to some of that data, and then turn those environments off, or whether it's bringing some of that data into a managed data warehouse, such as Amazon Redshift. It also allows us to apply multiple compute resources at the same underlying source of data. So we can have data sets residing in S3. We could spin up multiple EMR clusters, each with different applications installed of them, all of them processing the same underlying data at the same time. So how do we get data into our data lake? Well, there are a number of different mechanisms that we can use here. For batch and file and large object upload, we can use the S3 APIs and S3 transfer acceleration. For streaming data that might be generated by IoT devices or logs on your application servers or mobile apps, we can use things from the Kinesis family of products, in particular Kinesis Streams and Kinesis Firehose. If we've got a very large volume of data that we want to bring across from our on-premise storage into AWS, potentially we may have many terabytes of data, then we can use a Snowball device. This is a ruggedized device that will allow you to copy up to 100 terabytes of data onto that device. It's then shipped to AWS, and we will then put that data into S3 into the appropriate region that you've specified. If you have on-premise relational database sources, we can use the database migration service to do batch and streaming change data capture. And we can bring that data over, we can target a relational target within AWS, but we can also bring that relational and data warehousing data over and write it directly to S3. So lots and lots of different mechanisms for getting that data into our data lake, whether it's batch or streaming data. So that's the kind of fundamental storage characteristics of our data lake. But what we're also discovering that storage by itself isn't a sufficient basis for an analytics platform. What we really need to know is, what data do I have? Where did it come from? When was it created? What format is it in? And who can access it and what can they do with it? So at a minimum, we need to be able to discover sources of data, infer schema, and store and version this metadata. This then becomes the basis for data discovery and data lineage. So to help out here, we have a relatively new AWS service, AWS Glue. So Glue has three fundamental capabilities. Firstly, it provides a data catalog, and that's what we'll concentrate on over the next couple of slides. But on top of that, it also provides for managed ETL and managed job execution, scheduling and execution, which we'll look at a bit later on when we come to data preparation and processing. Glue's data catalog provides you with an account-wide Hive Metastore compatible, highly available metadata repository. Okay. So this allows us to identify sources of data within our AWS estate and upload that metadata into the repository. And then those external table definitions can be consumed by a variety of different tools. We can use those table definitions within Athena, which is effectively our managed interactive query service, allows us to write SQL directly against data in S3. We can use those external table definitions via EMR, so Hive or Spark on EMR can again address those tables and the underlying data that resides on S3. And we can also query that underlying data using Redshift Spectrum. So it's a facility of the Redshift Managed Data Warehouse that allows us to join data on S3 with data that's held in local attached storage within the Redshift cluster. So all of this metadata held in the Glue's data catalog and available for multiple tools to consume. Now, what we've done with Glue is add a nice little feature called crawlers. So you can provision a crawler and you can point it to a specific portion of your AWS estate, perhaps to a specific key space within S3 or to a JDBC endpoint for a relational database or for data warehouse. And whenever that crawler runs, it will attempt to discover new sources of data. And if it finds a new source of data and it understands the format, it will apply a classifier. If it understands the format, then it can sample the data, infer the schema, and automatically upload the metadata into the catalog. So this is a wonderful automated mechanism for populating your data catalog, for discovering sources of data within your estate and then automatically populating the catalog. If one of those crawlers runs several times over the same portion of S3, for example, and discovers new sources of data the second or the third time it runs, and the format or the structure of that data has changed slightly, if the crawler believes that it's still reasonably similar to what it's seen previously, then it will version the metadata in the catalog. So Glue's data catalog effectively allows us to capture and store version metadata describing all of the sources of data within AWS. And then we can supplement the catalog with additional indexing and search facilities. Again, we can use those events that are generated by S3 whenever a new object is written or deleted, and we can use that to trigger some additional indexing. We might store metadata or additional metadata in DynamoDB, and we may store unstructured data, certain text fields and so on, in Amazon Elasticsearch. And so the data catalog, DynamoDB, and Elasticsearch provide us with a comprehensive discovery and search mechanism for all of that data that resides in our data lake. Okay. Let's move on to governance, security, and privacy. The basis for all security across all AWS services is our identity and access management service. This allows you to manage users and groups and roles, and then to attach policies to specific resources or specific services that govern who can access that service and what they can do with it. And in the context of S3, we can attach policies to specific buckets describing who can access the objects in those buckets, who can list them, who can modify them, who can create them, and so on. So in terms of our analytics platform, we can use identity and access management to secure data at the lowest layer, at the data level itself, at the storage layer. And then we can also apply those policies to the APIs across all the other services that we use to access and process that data. So it gives us a very comprehensive fine-grained control over securing the data itself and the ways in which that data is used and consumed. We can then layer additional security mechanisms on top. So if you're using applications from the Hadoop ecosystem and you want to introduce row-level security, for example, or you can use things such as Apache Ranger. What we have here is a link to an article that describes how you can use Ranger together with EMR to provide that more fine-grained access control for the data that you're consuming through EMR. In addition, we have very comprehensive auditing capabilities built into the platform. Those logs can be written to CloudTrail, and then in turn we can use Amazon Athena to query those logs and understand the ways in which our data is being accessed and consumed. We also have multiple choices with regards to the ways in which we encrypt that data at rest. In its simplest, we can use AWS server-side encryption, where we're responsible really for managing the keys. If you want to take more control, if you want to control your own keys, control when they're rotated and so on, then you can use the AWS Key Management Service. If you want dedicated hardware, then you can use AWS Cloud HSM. So a comprehensive range of facilities for encrypting data within S3 and across the board. Okay. When we looked at those four fundamental concepts for our data lake, at the top there, we were talking really about APIs and UIs, about the ability for our end users and for other applications and services to be able to access the data that we have in our data lake. So we may want to consider introducing additional APIs on top of the lower level APIs that are exposed by things such as S3 in order to provide more business meaningful or application-like semantics for accessing specific data sets within our data lake. And one of the things that we can use here is Amazon API Gateway. With this, we can build application or domain meaningful APIs and expose them to end users either via SDKs or through REST services. API Gateway provides throttling and monitoring of incoming requests, and in the back end it uses Lambda to implement some other logic. So we effectively have multiple options for the ways in which we expose our data to our end users. We've got some of the low-level S3 APIs. If we're using certain tools, whether it's Athena or redshift, these in turn expose their own JDBC endpoints. But it may be that we further want to encapsulate all of that access behind an API that we control. And we can use API Gateway together with Lambda in order to build that higher level API over our data lake. Looking now at things such as data quality, data preparation, and the orchestration and scheduling of specific jobs. And here again, we're going to end up talking about AWS Glue. So I said earlier that Glue has three fundamental capabilities. We looked at one of them, which is the data catalog. The other two capabilities are around managed ETL and the ability to be able to schedule and execute any jobs that we create via Glue. So Glue allows us to create transforms. Given a source and a target from the data catalog, create for me a transformation. Glue will then create for us an ETL job that will take data from the source, transform it, and push it into the target. Under the hood, It's actually creating some code, some Python code that addresses the Spark runtime, so some PySpark code. You can open that code up in your own IDE or in the browser and further modify it to further enrich the data or the processing. In addition, you're not confined to using the skeleton or the auto-generated code that Glue provides. You can bring your own PySpark code to Glue and have Glue execute that on your behalf. So having created jobs within Glue, we can then describe how we want to schedule and execute those jobs. We can schedule them on a periodic basis, or we can schedule them based upon specific events. For example, we might say that this job over here should execute when this job over there completes. Or it may be that we want this job to effectively provide some rollback capability if this prior job terminates or fails for some reason. We can also trigger those jobs, again, using that S3 eventing mechanism. A new object lands in S3, we can have a Lambda function trigger the start of a new Glue job. So in this way, we can build dependency trees of jobs that will effectively transform our data as it's progressing through our data pipeline. So putting together the data catalog and the managed ETL parts of Glue and plugging in some of our analytics services, this provides for a very, very powerful, very simple mechanism for being able to ingest, transform, and query your data within S3. We can consume data from multiple sources, land it in S3, catalog it using Glue's data catalog and those crawlers. We can transform it using the managed ETL capabilities of Glue, and then we can query that data via services such as Amazon Athena, Redshift Spectrum, or Hive, or Spark SQL running on EMR. So that's briefly surveyed some of the services that you might use in order to build that foundational data lake-like platform. Just a couple of other points really about when we're going to implement this. First thing here is we don't really want to just try and dump all of our data all of a sudden into this S3 data lake-like environment. We'll just end up with a swamp. The best way of beginning to implement a data lake-like solution is to start with specific use cases or workloads and to work backwards. Think about the product, the business meaningful or the application meaningful data sets that you want to expose to your analytics users. Then identify the raw sources of data that you would need to process in order to generate that product. So that gives us the two ends here. We can then identify the specific transformations that we would need to undertake in order to take those raw sources and to generate those derived data sets or that product. And just a reminder here that S3 isn't simply dumb storage. We can effectively use a number of features within S3 and a number of complementary services in order to provide a comprehensive data lifecycle. So we can use S3 prefixes. So effectively S3 is based on a key value model. The key is a URL-like structure that places an object within S3. The value is the object itself. We can use those prefixes to separate data and to partition it. We can use the data catalog to create version metadata that's grouped on by way of a metaphor of databases and tables. We can use things like DynamoDB and Amazon Elasticsearch to provide additional indexing capabilities. We can use those S3 lifecycle policies to delete data, perhaps some of that raw data, we don't need it once we've applied some transformations to it, or we simply want to archive it for long-term storage, perhaps for auditing purposes. We can use S3 lifecycle policies for that. We can use buckets, tags, bucket policies, and access control lists to control ownership and classification and access control. And then we can use things such as CloudTrail and S3 access logging in order to implement comprehensive auditing capabilities around all of that data within our data lake. So briefly, just bringing all of this together in the context of a single kind of reference architecture diagram. On the left-hand side, we have a number of different ingest technologies, for streaming and batch ingest, and for bringing over large volumes of data from on-premise into S3. We have our centralized storage mechanism, which is S3 plus Glue's data catalog. And then we have some additional cataloging and search capabilities with Dynamo and Elasticsearch, and comprehensive access control, and auditing and key management. And then over on the right-hand side, we have a range of services that help us apply that data for a specific use case. So we can choose the most appropriate tool for the job at hand, pointed at the underlying data stored in our data lake. So we focus very much on that store all your data forever at every stage of its life cycle. That's really the foundational, the core element of our data lake. But this then gives us the ability to apply our data using a range of different applications, tools, and services. And obviously there are a number of different ways in which we want to apply that data. We may want to do some data processing or data warehousing, all the way through to actually building predictive analytics or undertaking some near real-time streaming analytics on top of the data as it's being ingested. So we can actually expand that box on the right and describe in more detail many of the different tools and services that are available within the AWS ecosystem for applying your data. We have a number of different services for batch and interactive querying of the data. That includes things such as Amazon Athena and Redshift. We have transactional applications, and again, this goes back to some of the stuff we talked about a few weeks ago. We have things like DynamoDB and the Managed Relational Database Service. We have a large suite of BI and visualization tools that we can use to consume that data. We have Amazon's QuickSight, but then we have a number of tools within the marketplace and provided by AWS partners that also work very, very well with this platform. For near real-time and streaming analytics, again, a comprehensive set of technologies ranging from Kinesis Analytics, which is effectively managed serverless SQL over streaming data, over the Kinesis streaming data, through to a number of different streaming technologies that we can build on top of EMR. That includes Spark Streaming, Flink, and so on. And then finally, we have a wide variety of machine learning and AI capabilities and frameworks that we can use pointed at the data within our data lake. Now, the beauty of this architecture is, within this large box on the right-hand side, these are the things that effectively we have access to today. But that may all change in the future. These services, tools, and technologies are undergoing rapid evolution. The nice thing about separating out these concerns, the underlying storage, store all your data forever at every stage of its life cycle, separating that out in the ways in which we apply the data, means that we can introduce new tools and technologies, we can experiment with them, we can spin up clusters and have different parts of our organization using different tools, but all pointed at the same underlying data within our data lake. But the services aren't the be-all and end-all. The AWS ecosystem is larger than the services we offer. It also includes a very large number of AWS partners. And those partners offer additional software and services that complement what we have within AWS, but they also offer consulting and delivery services that can help you build and operate your data lake-like platform. And that brings me nicely to the second half of the session, where we're going to hear from two of our partners around the work that they're doing with their customers in building out data lakes on AWS. So I'd now like to welcome Kieran Tamana, who's the EMEA Head of Solutions Architecture for DataPipe.
Thank you, Ian. So just wanted to start with who DataPipe are. As of last week, we're now a Rackspace company. What we essentially offer are managed services across both public and private cloud sectors, managed hosting and co-location. What this kind of acquisition demonstrates and brings to the market is a collective commitment to becoming the world's #1 service provider within the IT market. And for the last 6 years, DataPipe has been a premier global partner, both in the European markets and North America. We're a market leader in the hybrid and public cloud environments, which is recognized by Gartner, and you'll see that on the Magic Quadrant. But over the last 6 years of being a premier AWS partner, we've kind of gained a few consulting partner competencies. And to name a few, there are the Microsoft workloads, there's Microsoft, there's migration services, there's Direct Connect, and over the years we've kind of gained a lot of experience and a lot of use cases with these kind of services. But that's just a very brief overview of what we do. Let's talk about how we've used data lakes for a client and how it's kind of benefited them going forward. Here we go. So our use case that we're going to discuss here today is about a client that manages a global network of specialist sources of business critical maritime data. This data comes from a variety of data sources in multiple formats. What this data consists of is things like real-time satellite locations. So if you have a look at a diagram, you'll see a section of the globe where all these green kind of marks indicate different vessels that are in different points of different areas and locations, and that's being tracked by a certain, we'll come to listeners, which we'll come to. We'll also track real-time capacity management and facilities, so what kind of these ships are carrying and what those characteristics are. And other data such as registration documentation and ownership and who owns what, when, where, and when it will arrive to which area that is kind of their destination. Once all this data is collected, it is then monetized and provides a subscription-based up-to-the-minute information services specifically for the maritime industry. They are now currently delivering real-time news and data analytics to over 25,000 plus users across the globe. The business intelligence service enables the end users not only to identify route improvements and maximize fuel efficiency at a micro level, but also gives a real strategic insight into the industry-wide changing trade flows geographically, as well as understanding which shipping companies are growing or declining and their fleets and the size of those fleets. At the heart of their intelligence service is an integrated database which stores specific and significant amounts of unstructured and structured data. And we'll talk about in the next slide how we as DataPipe approached this situation and how we helped this specific client to improve their services. Currently, I mean, as you can see and as you can imagine, there's a lot of data that's being consumed and generated, and we need to make sense of it and understand it so that the end users can kind of gain and use it appropriately. If we move on to the next slide. So DataPipe's approach is founded on the promise of putting planning before actual action. And this is kind of proven with the experience that's given us a unique insight to the best ways to uncover every infrastructure requirement, what the applications, what the data actually means to the business and the end users, and what implications that data would then arise going forward. Migration of these products, such as Data Lake into Data Lake, are delivered as part of an overall DataPipe methodology, and they're based on four key aspects. Those four key aspects are to assess, to architect, to build, and then to run. In the assess phase, we'll kind of conduct workshops and application streams, and we'll whiteboard and look at existing applications and stuff like that. And from that, we'll start kind of developing build documentations, diagrams, that sorts of stuff. We'll then start architecting, and we'll look at a more deep dive with collaboration with engineers what the future state would look like, what the environment will, how we can make it more efficient, more cost effective, that sort of stuff, and we'll kind of look at how that architect will bring or solve the problems that will initially arise. We'll then start building the environment, and then we'll start looking at how, from the original requirements section, how we kind of move it into a BAU state and ongoing management of that environment. But now let's see what it actually looks like, and for this specific client, what we actually did for them. So as Ian mentioned, there are three key kind of aspects of data lakes, and that is firstly, let's talk about the ingest side of things. So for this specific example, we have all these ships sailing around the whole globe in various different locations. That data is then sent into a kind of ELB within a specific region. And behind that, we have these things called AIS servers, which are essentially listeners, and they're data collection points. And the ships are sending via TCP connection data of various nature into those specific regions, into those instances. And with those instances, we then pass it on to an SQS queue. And the SQS queue is there specifically so that all data is captured once and processed once and never duplicated. And it's all collected at that kind of point where it then passes into these individual AIS listeners. So we have one for sightings, which is obviously to do with around the location of vessels, the moves, how we can move that data across different platforms, and things like specific client listeners. So every client of this organization would have a different use case for using this data and how it gets processed. Within that, it's kind of, at this point, it's kind of unstructured, but to structurize that data, we'll use stuff like Athena, we'll use things like what Ian's just mentioned, the AWS Glue function, and then we've also created some Lambda functions to kind of make sense with all this data and what it actually means, and applying metadata into it, so that when it sits in S3, clients can then use that data more intelligently. With this specific client, we use BI tools in the background, where they then sell this data onto their third-party clients and use it in a much more efficient and a more cost-effective way. And from that, we can then set up specific rules to then archive some of that data which isn't existent, but archive it in things like Glacier, where we can keep it for 7 years and use that productively. That's kind of a very high-level overview of how we've used data lakes for a specific client here. I'll now pass you on to Derwin, who is from Cloudwick, and he'll go through some of their stuff. Thank you.
Thank you, Kieran. Hello. So my name's Derwin McGeary. I'm a solutions architect at Cloudwick. So I'd like to just give you a brief rundown on Cloudwick, the organization, and then look at our reference data lake architecture on AWS, and move on to seeing how we've implemented that reference in practice with a client. And finally, I'll show you, if you decide to get your feet wet, how you can get started. So, Cloudwick was started about 7 years ago in Silicon Valley. We now have 3 global offices in the US, EMEA, and APAC regions. Our main value is our professionals. We have 150, I think it's now 200 professionals with more than 400 certifications. Our initial focus was in Hadoop, and we found that for a lot of our clients, the challenge was in orchestrating all of that infrastructure. So we have added a focus on AWS, and we are now an AWS technology partner. The through line for our business is big data. We like to orchestrate big data, we like to make it move, keep it safe, and make it useful. Our clients, you can see, are in the Global 1000. So our reference data lake architecture, as Ian has already said, we have our layers. So we have defined the data ingestion layer. There are many ways for data to come into AWS very easily. This then ends up in the data storage layer, where the raw data can sit on S3, where it is highly available and highly durable and stored inexpensively. That can then trigger transformations to produce a curated layer. This data is useful. It's ready for end users, and we then have an analytics layer, which is a data warehouse using redshift, which can be spun up on demand. And we can make that accessible to our clients using traditional JDBC or ODBC connections, or using the API gateway. We can allow for advanced analytics and things that you can't do with SQL. So I'll have a look at some of our clients that we've worked with. With IFPI, we were using advanced streaming analytics, using Spark streaming on EMR in order to identify copyright infringement. We were checking millions of records per hour with an approximate matching algorithm, and then storing them to S3 for later processing as better data becomes available. With the UK data service, we set up a hybrid on-cloud, on-prem Hadoop environment. We're G-Cloud certified, and it was important for the UK data service to have somewhere highly durable and highly available to store their data. But it had to integrate with their existing systems, and fortunately IAM on AWS provides that facility. And the client I want to talk about today is SGN. So SGN is one of the largest gas distribution companies. It has 71,000 kilometers of pipeline in the UK, and it has spent hundreds of millions per year on maintaining and upgrading that network. In addition, there are reporting responsibilities. This is a highly regulated industry. Due to the nature of the company, the data is often in silos. It lives in a traditional data warehouse, and it is often understood by specific people within the companies, which makes end-of-year reporting, when these data sets have to be brought together, a nightmare. So they want better. They want something to be more open and more systematic. So the challenges for them was that their existing ETL process was less planned but more evolved. It had grown over a number of years to 3,000 lines of SQL code, and obviously it's hard to get intention from code. There is also no single point of access to the data, and there was a certain amount of duplication. So our solution was to take the opportunity to, instead of translating code, which doesn't really add value, to take the opportunity to rationalize, to discuss which transformations were being made, and to adapt that to a cloud-native way of thinking. We wanted to be serverless as far as possible, and to react to the presence of data, and then using API and JDBC so that the data, which will be transformed and live in one place, is accessible openly. So here we can see what we actually implemented. We have step 0 is to use the database migration service to have a copy in the cloud of the on-prem database, at which point we can dump that to our raw storage bucket on S3. We use Lambda functions to note the availability of that data and start a transform process. We're using here Data Pipeline and PySpark. As Glue becomes available, that PySpark code will be migrated. So we implemented this looking to the future. In addition, so as not to migrate the entire database multiple times, after the initial load, we're only doing change data capture, and each incremental load then goes from the raw bucket to staging to clean. And because we have this automated and well understood process, we can make strong statements about the data in the clean bucket, that it is ready to use, that it is well formatted, and that it can be loaded into Amazon Redshift for further analysis without further transformation. So there's a hands-off scheme there. And we have simple notification service here to tell users that this data is available and ready to use. So you may be looking at the top corner and saying, well, why not just use the RDS instance in the cloud? That would take away the pain of managing a database by having a managed instance there. But fundamentally, we want to store the data in a ready-to-use format on cheaper storage. And if we are not analyzing the data, we do not want to pay for the infrastructure to analyze the data. So we have a Redshift which we can spin up on demand. If we're not using it, we'd rather not pay. So that is how we do this in practice. If you want to get started on this, then a good way to think about it is to look at the data and the metadata you already have. Take this as an opportunity to think about your data. You may have specific needs in mind, you may have specific things. Think about not only what you want to do, but what you don't want to do. You can assess the value of your data, and if you're ready to get your feet wet, then I can recommend we have a Cloudwick Quick Start. If you have an AWS account, you need nothing else. You can go to this link and spin up an example data lake on your AWS account. If you want to go a little further, Cloudwick offers the opportunity to use a jumpstart. So that is an engagement in partnership with AWS, where we will come and work with you to look at your data and see where we can organize to make your data more available in the data lake. So I do encourage you to spin up things. AWS makes it very easy to launch some serious infrastructure. And thank you very much for your time.
Wonderful, thank you, thanks Owen. That's perfect timing. We've got 10 minutes left, and in that time we're going to try and take some of the questions that people have been submitting, and I'm also going to turn on my video camera so you can actually see the people who've been talking to you today, better or worse. So I'll give that a go.